Hi everybody, this video is about rational exponents, that is fractional exponents, and radicals, roots, and how they're actually the same thing. So, long story short with this first example, when you have a fraction exponent, a rational exponent, where there's a 1 in the numerator, like we have, the denominator is indicating a root. So, 6 to the 1/2 power is nothing more than the square root of 6. Now, since we're going to be using some higher order roots in a little bit, please note that when you write a square root, there's an understood 2 next to the radical, that this is a square root. You don't write the 2, but when you write a cube root or a fourth root, for example, you do write that number. So, 6 to the 1/2 power means the square root of 6. These are the same things. And this is really the purpose of this video, that a fraction exponent and a root are literally the same thing. So, let's look at this example. Well, 10 to the 3/4 power is different from the previous example because there's not a 1 in the numerator. Rather, there's a 3. So we're going to use an old property of exponents. If you have a power raised to a power, you multiply the exponent. So 1/4 times 3 is 3/4. So I haven't changed the problem, I've just separated the exponent into 2 pieces. And now we'll take what we learned in the previous question. A 1/4 power is a 4th root. And then we're going to take this 4th root and raise it to the 3rd power. So on the left we have exponential form using exponents, and on the right we have radical form. So we can go the other direction as well. We can start in radical form and change back to exponential form. So the base is 5. We're raising it to the 5th power. And then we're taking the cube root, which as an exponent is 1/3. Let's do another. So our base is 3. We're raising it to the 3rd power, and the root is a square root. There's an understood 2. So the problem we started with, written in exponential form, is 3 to the 3/2 power. So fraction exponents and roots are literally the same thing. Now, when we get to using doing arithmetic with these, it takes a little practice. So 36 to the 1/2 power, well, that means the square root of 36, and the square root of 36 is 6. Now there's no reason to show the work here, you can just write the answer, but it relies on you knowing that 1/2 power means square root. So what about something like this? Again, if you see the answer, you can just write it down, but until you get that practice, you might want to show a little bit of work here. So 9 to the 3/2 power. Well, that means the square root of 9, and then raise that to the 3rd power. Remember, the numerator is a power, the denominator is a root. And do this in as many steps as it takes. The square root of 9 is 3. And then we're raising that to the 3rd power. 3 times 3 times 3 is 27. We'll do a few more of these. Like I said, this is something that takes a bit of practice. So whether you're showing work or not, you have to take the cube root of 8 and then raise that to the 5th power. The cube root of 8 is 2. We're raising that to the 5th. 2 times 2 times 2 times 2 times 2 is 32. I think I have a few more of these. They're relatively quick though. You might think that this question would be difficult. You're taking the 5th root of 100,000. That seems like it would be quite a bit of arithmetic. So we need a number multiplied by itself 5 times, so 5 copies of that number. When you multiply it out, you get 100,000. We're squaring it. So the 5th root of 100,000, if you just count the zeros, Well, that's going to be 10, because 10 times 10 times 10 times 10 times 10 is 100,000. So we took the fifth root and got 10. Now we're squaring 10. 10 squared is 100. Okay, what about negative exponents? This is almost, well, not almost, it is the same thing, but there's one more step. We have 8 to the 1/3 power. We're going to square that, and we're going to raise that to the -1. So power to a power to a power, you multiply the exponents. 1/3 times 2 times -1 is -2/3. So we do this in 3 steps. 8 to the 1/3 power, that means the cube root of 8, which is 2, because 2 times 2 times 2 is 8. We still have our power, we're going to square, and then we're going to deal with the negative exponent. So 2 squared is 4 to the -1. And our property for negative exponents is we take the reciprocal of our base, so the reciprocal of 4 is 1/4, and you change the sign of the exponent. So 4 to the -1 becomes 4 to the +1 when we move the 4 to the bottom, if you want to think about it in that way. Okay, I think I have one more problem here. So same thing. We have 16 to the 1/2 power, which means the square root. We're going to raise that to the 3rd power and raise that to the -1 power. So 16 to the 1/2, that means the square root of 16, which is 4. 4 to the 3rd, that's 4 times 4 times 4, which is 64. And then 64 to the -1 is 1/64. Anyway, that is how you deal with rational exponents. Just remember, it's the same thing as taking roots. And later on in your mathematical career, this will really help you understand logarithms, whatever those are. Anyway, hope this video helped. See you next time.